13,000 years ago, an apex predator roamed the earth. A massive, bone-crushing beast known as the dire wolf. It was bigger, stronger, and fiercer than any wolf today. But then, like many ancient creatures, it vanished. The dire wolf became one of the most iconic species lost to extinction. Or so we thought. Now, in a move that seems straight out of Jurassic Park, scientists are bringing this long-lost predator back. But the question is, what does it mean to revive the dire wolf? Is it a true resurrection? And what impact will this have on our ecosystems? Today, we'll dive into the science behind the de-extinction of the dire wolf, what it took to bring it back, and the ethical and ecological dilemmas surrounding it. Welcome to Earth for Beginners. Here's where it gets truly fascinating. How do you bring back an extinct species like the dire wolf? Well, it starts with a cutting-edge technology known as de-extinction, a process that involves using DNA from ancient remains to bring a species back to life. To resurrect the dire wolf, scientists first needed to find well-preserved DNA from ancient remains. Thankfully, fossils, such as teeth and bones, have been preserved in tar pits, caves, and other fossil-rich sites. Scientists carefully extracted fragments of ancient dire wolf DNA from these remains. But there's a huge problem when working with ancient DNA. It's fragile and fragmented. DNA from creatures that died thousands of years ago often degrades, breaking into tiny, incomplete pieces. This is where things start to get a little tricky, but modern technology has allowed researchers to recover just enough to piece together the genetic code. So, how do they fill in the gaps? Scientists turned to the gray wolf, the closest living relative of the dire wolf. By comparing the genomes of modern gray wolves to the ancient dire wolf DNA, researchers identified key genetic differences, traits that helped the dire wolf grow larger, stronger, and more adapted to its environment. Enter CRISPR-Cas9, the gene editing technology that's revolutionizing everything from medicine to agriculture. With CRISPR, scientists can cut and paste specific genes into a new genome. In this case, they edited the DNA of modern gray wolves to insert genes responsible for the dire wolf's size, bite force, and other physical traits. This process isn't cloning. Rather, it's genetic modification, a way to recreate the dire wolf's essential traits without creating a carbon copy of the original. In January 2025, after many trials, the first genetically edited dire wolf pups were born. Their names? Romulus, Remus, and Khaleesi, the first pups to embody the traits of their ancient ancestors. This brings us to an important and often debated question. Is this really a dire wolf? The short answer is no, not exactly. These new pups may look like dire wolves, larger, stronger, with more robust jaws, but they're still fundamentally gray wolves at their core. The reason for this is that we're not talking about cloning the dire wolf, which would involve using the original animal's complete genetic code. Instead, we're editing the genetics of modern gray wolves to recreate the traits that made the dire wolf unique. It's like restoring an old car. Imagine finding a rusted-out 1960s classic and then replacing parts with modern equivalents. It might look like the original car, but it's not quite the same. Similarly, these pups are genetically modified gray wolves, not true 100% dire wolves. They carry some of the genetic traits of their extinct ancestor, but they aren't a perfect replica. This leads to a larger philosophical question. What does it mean to bring back an extinct species? Is it enough to reintroduce an animal that shares the same physical traits? Or does a true resurrection require restoring the animal in its purest form, genetically, behaviorally, and ecologically? This is something scientists are grappling with as they move forward with the project. But it's important to remember that these pups are still a remarkable achievement in genetic engineering, even if they're not 100% authentic dire wolves. Thanks for joining me on this journey through the science of de-extinction and the return of the dire wolf. Whether it's a step toward ecological restoration or a risky experiment, we're entering a new era in conservation and biotechnology. What do you think? Should we bring back extinct species like the dire wolf, or focus on saving the ones we still have? Let me know in the comments. If you enjoyed this video, don't forget to like, subscribe, and hit the notification bell to stay updated on future videos. Until next time, stay curious!